To welcome you. Hi Alex.
Hi.
I'd like to welcome you to the Highcon booth, or the corridor anyway. It's the best looking audience we've had this morning so far, which is good. I'd also like to introduce Yuri, who will be operating the machine, and of course the star of the show, the Highcon Euclid, which is the world's first and only entirely digital cutting and creasing machine production device. What you're going to see is a revolution in the production of folded cards. This is like nothing else that exists. And what we're going to do is a live job for you. And from time to time on the screen, unless the guys are messing around, they're going to set me up with something. There's a camera inside the machine, and you'll see some things going on, but I'll explain what's going on later. All right. So what we really want to show you by this job is the contrast between the way it's done now in an analogue way on a traditional die cutting machine and how it's done digitally. Because as you know, an analogue machine, which has been around forever, is relatively inflexible. It's expensive and it requires very high skill set to operate and also of course to make the dies. Whereas this machine is fast, responsive and allows the customers to get what they want when they want, and it also has a lower total cost of ownership. And it also requires, no offence, lower skill sets to operate the machine. The first thing you should be aware of, and for the converters amongst you, you'll understand this, is that it requires no die. There's no conventional die in this process at all. And for those of you that are less familiar with the process of die making and so on, when a job is approved for production, the converter sends out for the job, the die to be made. Now, if the end customer is prepared to pay extra, then the converter may get this made within 24 hours. Quite often, it will take 2, 3 or 4, 5 days to make the die, depending on the complexity of the job. This seems incredible, but this is the way it's done all over the world. Then the die has to be transported back to the converter, and the converter has to fix it into the traditional machine. Now, if you have a great operator, it's not running that fast, the job's not that complex, and the wind's in the right direction, and the right moon phase, Mr. Tracy, then it can be done in 24 hours, but often it will take 2, 3, 4, even 5 hours to set up the machine, depending on the complexity of the job, as I said. Now, while that's happening, the converter is making no money at all. No money at all. And the end customers not getting what they want. They're not getting their job. Now, those converters could have spent hundreds of thousands or even $1 million on a machine that for 30, 40 or 50% of the time does nothing. Seems incredible. All around us, Hall 9, this hall, you'll see digital equipment being introduced. Why? Because it's fast and it's responsive. It's a big difference. Time on digital machines, your flight has been cancelled, thank you. Better than your flies are undone. Digital machine, time is measured in minutes and hours, not days and weeks, as it is with conventional die cutting. Lots of other things going on over here. It's the last day, but we're getting there. Time between jobs on this machine is about 15 minutes, so it's radically different. And that changes the economics of the process. So if you're a converter and you have work in your portfolio from your customers that is 10,000 sheets or less, then this makes huge economic sense. You can now go to your customers and ask for that short to medium run work, whereas before you probably said, no, I'm not interested in that, I might even make a loss on it. Or better still, you can go to someone else's customers and ask for their short run work. So how does this machine function? Well, you see some crease lines being written there, but I'll explain that more in a moment. When the job is received, and by the way, it fits into the current production environment because it takes DXF files, so from the common production software packages, and also it's B1 or 3B format, so it takes output from conventional presses. The first thing that happens is the operator loads this simple foil onto a drum. It takes 1 or 2 minutes, takes Yuri 30 seconds. And then a writing head, which is the process you saw earlier, writes crease lines with a polymer we've developed onto this foil. Now that just takes minutes, as you saw, even to write a complex die. So you're just doing the crease lines on here. Now that writing head writes on here at 8 meters a minute, so it really doesn't take very long at all. And the nozzle defines the height, width and the profile of the crease lines, depending on which nozzle you load into the machine. Quick to change. The next process is that the drum rotates slowly 3 times, which again takes just a few minutes. And this UV cures the crease lines and makes them tough and hard. So you can do up to 10,000 impressions just on one of those foils. The operator is going to load in information about which substrate you're using, simple, or just recall previous information. Going to load the card into there, and then that is it. You're ready to run. So it's completely different from any process you've seen before. So when you kick the machine off for production, it picks up the substrates from here, and they're transported on a conveyor belt all through the machine. It doesn't stop-start, and there's no 300 tons going up and down. It's really simplified. It's gripped on the gripper edge from the press all the way through the machine, so you get great registration. The first thing that happens is the substrate passes between the nip of the 2 rollers. On the upper roller you've got the crease lines, and on the lower roller there's a special substrate that we've developed. It's like a blanket, it's a soft substrate, it's a counter that you can use many times. Very, very simple and fast process. The card continues through the machine, and here we have the cutting station. And in the cutting station there's 3 high power lasers, 3 400-watt lasers with a scanning device we've developed and our own optics. So the cards cut precision, speed and accuracy. And of course you'll see the quality in a moment. So there's no stop-start, it continues and then comes out into the stacker at the end of the machine. Now some people, even for short run, would like stripping, so by the middle of the next year we'll have a stripping option for this machine, and by the way that will use no tool either. Everything's going to be entirely digital, so there's no additional costs for some stripping tool. Just so you know, this machine will be available by the end of this year. We start shipping. Customers have ordered machines already and we've taken letters of intent for machines for the end of next year as well. So it's been really, really successful. So if you want to know more about the machine, the precise specifications, do come and see us and the cost model. No problem at all. We're delighted to talk to you about it. Now we're going to, in a minute, take out the samples, put them on there. You can have a look to see what we're producing. And you're welcome to come and talk to us. Thank you very much.